Hi everybody. After our initial introductory lesson on arithmetic sequences, we're going to have a look now at a few more of the things that we can do with an arithmetic sequence. So we're just going to go through the examples, starting with example 1 on page 2 in your textbook, in your booklet rather. The first thing you're being asked to do is to complete the table. You need to recognise that there's a difference of 9 between each of these two terms, which means to find the fourth term, we need to add 9, which is going to be 41. Be very, very careful. It's tempting to go and fill in the rest of the table, except that the numbers are not consecutive. So you need to be careful to make sure that you add on the right number of quantity of 9s to get the right answer. So the sixth term is going to be 2 lots of 9 more than 41, which is 59. The eighth term is 77. 15th term is 140. We'll come back to the nth term in a minute. If you have difficulty sort of recognizing what these terms are, don't worry too much. You can get enough information out of the first few terms in a sequence and then come back and fill in the table later. So looking at question B, what's the common difference between the terms? The common difference is going to be 32 take 23, which is 9, and confirming 23 take 14 is also 9. So D, the common difference, is 9. If T of n is used to represent, or Tn rather, is used to represent the general term or the nth term of the sequence, find the general term. So our first term, which we sometimes call A or T1, is 14. Our common difference is 9. So we put that together in Tn equals A plus n minus 1 times D. That's our general rule. So in this case, Tn is going to be 14 plus 9n minus 1, which is 14 plus 9n minus 9, which is 9n plus 5. So Tn is 9n plus 5, and that is the general term. And you can see that that is an explicit formula. From here, we can now use this information to decide whether a certain number is a member of a term. So we check, is 2111 a member of the sequence? Well, we let it equal 9n plus 5, which is our general term, and then work out what n is. So we take 5 from both sides, and we're left with 2106 equals 9n. We divide both sides by 9, and we're left with n equals 234. Now, there are two conditions on n. First of all, n must be greater than 0. Second of all, n must be an element of the integer set, as in, it must be a whole number. In this case, n is 234, which is both greater than 0 and a whole number. Therefore, 2111 is T234 and is a member. Same thing with question 4. This question 2 rather, is 4 a member of the sequence? Now, first of all, we can check that T1 is actually equal to 14. So T1 is 14. That means the smallest member of the sequence is 14. 4 is less than T1, therefore 4 is not a member. If you miss that, you can go and do it exactly the same way as you did the previous one. So we can say 4 equals 9n plus 5. Take 5 from both sides to give us -1 equals 9n. We divide by 9, n equals -1/9. N is less than 0, and n is not an element of the integers, therefore 4 is not a member. Okay, and you need to put these condition statements, so your justification of why 4 is not a member. Is 1,423 a member? 1,423 equals 9n plus 5. Take 5, take 5. We've got 1,418 is 9n. Divide by 9, divide by 9. N is 157.5 recurring. N is not an element of the integer set, therefore 1,423 is not a member. And finally, find the fifth term. We can use our formula T5 equals 9 times 5 plus 5, which is 45 plus 5 is 50, so T5 equals 50. Now, before I said if you couldn't quite eyeball these last few terms, now that we've been through and worked out what the formula is, we can use the formula to work out those last few terms. And remember, we worked out that the nth term is 9n plus 5. So this one, term 6, 6 9s are 54 plus 5 is 59. 9 8s is 72 plus 5 is 77, and so on. So now that you've worked out the explicit formula, you can go back and fill these in if you were not able to just do it by looking. In the next video, we'll have a look at example 2.